Welcome to aminacademy.com. In mathematical formulae, let us discuss about formulas of determinants. First, what is determinant? Determinants are the scalar quantities obtained by the sum of products of the elements of a square matrix and their cofactors according to a prescribed rule. They help to find the adjoint inverse of matrix. Further, to solve the linear equations through the matrix inversion method, we need to apply this concept. First, second order determinants. Look at this example. Determinant A is you have to write the line like the elements are A1, B1, A2, B2. This is called row, this is called column. This is two rows and two columns, though it is 2 into 2 order matrix. So its value is, look at here, A1, B2, you have to put minus, and A2, B1. That means this arrow mark like and here. This is an example for the determinant of second order. Next one, third order determinant. Look at one example. Det A. Determinant of A is, generally you can write A 1 1, A 1 2, A 1 3, B 1 1, B 2 1, B 2 2, B 2 3, C 3 1, C 3 2, C 3 3. Simply you can write A1 B1, A1 A2 A3, B1 B2 B3 also you can write. Here this determinant is, look at here how to find this determinant. First A11 cross multiply of this one, B22 to C33 minus these two things, B23 C32 minus A12, that is A12 means this column and this row is removed and we have to do this one, B21 C33, B21 C33 and C minus C31 C31 and B22 C31 and B23 B23. Look at here one more time. This for the second, B21 C33 and C31 B23. Then with adding of A13, we have to write A into, that is A13 is that element here. This row and this column remove and here is this minor, B21 into C32 minus C31 B22. Then this simplify, that is open the bracket and simplify. Simply you can write this result as A11 A22 A33 plus A12 A23 A31 plus A13 A21 A32, this and with minus then minus of A11, A23, A32 minus A12, A21, A33 minus A31, A13, A22, A31. So this look like some complication, but if you practice it come easy. But we can do with Soros's rule of determinants very easier. Look at here. Soros's rule in the determinant, suppose determinant A is A, B, C, D, E, F, G, H, I, like this determinant. First of all, you have to write this determinant as, first as it is, you have to write the determinant A, B, C, D, E, F and G, H, I, and first column leave it, and second we have to go B, C, A, B, C, and you have to write first two columns, first two elements you have to write A, B, D, E, G, H. That means look at here, A, B, C, A, B, D, E, F, D, E, G, H, I, G, H. You have to write this. In this, look at this. Okay, you have to write this diamonds like A, E, I, B, F, G, C, D, H. Look at here, A, E, I. The elements are multiplied. A, E, I, B, F, G, and C, D, H. These are addition. Then subtraction come opposite manner. This side, G, E, C, H, F, A, I, D, B. Then this all subtracted from this. So we can find easily the determinants. This order you have to remember. Look at it, this and this way. Now look at one example for Soros's rule. We can easily find the answer. Look at here. First, the determinant A is given 2, 3, 5, minus 1, 4, 6, 3, minus 2, 7. This matrix. First we have to write these two things. 2, 3, minus 1, 4, 3, minus 2. We have to write in order. Just go this. Look at here. First, these red lines, arrows. 2 into 4 into 7. 2 into 4 into 7. 2 4s are 8. 2 4s are 8 into 7 is 56. 3, 6, 3. 18 plus 18 into 3 is 54. Third is 5 into 1 into 5 into minus 1 into 2. 5 into 1 is minus 1 minus into minus 2 is 10. So these are added 120. Then come this way. 5, 4, 3. 5, 4, 3 is 60. 2, 6 minus 2 is minus 24. 3, 1 and 7 is minus 21. This is total is here this total is 15. So 60, that subtraction is 15 here. Look at here. 60 minus 24 is 36 and minus 21 is 15. So we have to get 120 minus 105 equal 15. Therefore, determinant of A is this one. The source rule is very useful. If you understand the concept, it is quickly you can find the answer. Next one, nth order determinants. Nth order determinants, there are n rows and n columns. That's how to represent this one. A equal A11, A12, A13, blah blah blah, A1n. Like second row, third row, up to nth row. It is a first column, second column, third column, up to nth column. Here, these are the elements. A11 means what it is? It is a element of the nth matrix in first row and first column. Suppose this one is what? A23. It is first, second row, third column, like 2, 3. Next one, minor and cofactors. Minors and cofactors can be computed for each of the elements of a matrix minor of an element is equal to the determinant of the remaining elements of the matrix after excluding the two rows and columns containing the particular elements. The cofactor of an element can be calculated from the minor of the elements. The cofactor of an element is equal to the product of the minor of the element and minus 1 to the power of position value of row and column of the elements. So this looks complication, but we can understand by using some example. Look at here. For look, any matrix A and determinant. Look at here. 1, 2, 3, 4, minus 3, 2, 6, 0, 5. Here we have to minus here, right? There are 9 minors are there. For example, here the element that is A11, minor of A11, that right, minor of A11 equal, that means this one is which row, first row and in first column. So you have to remove first row and first column. You have to write this one, that is minor, it's minus 3, 2, 0, 5. Like that you can understand A21. Look at A21 is what? Is 4. Minor of 4 is this, we have to remove 4 is here, first row, first column and second row. That leaving this remaining things is 2305. 2305. Like that you have to write all. Suppose minor of this 0 is what? You have to remove this column and this row. The remaining things are 1, 3, 4, 2 like. Then you have to write 9 minus. What is cofactor? Here cofactor matrix, that is, which is the rule is Cij is minus 1 power I plus j with the matrix of M ij. For example, we have to find cofactor of this minor. Suppose look at here, this cofactor is, suppose cofactor of A11 is cofactor of A11. Look at here, A11 is here 1. So we have to write this minus 1, 1 and 1. I is 1, j is 1. I plus j is 1 plus 1. And that is minor, that is minus 3, 2, 0, 5. So which is equal, here 1 plus 1 is 2, minus 1 power 2 is positive 1 into minus 3, 2, 0, 5. Like that we can find cofactor of every elements. Suppose here, what is the cofactor of 6? Suppose cofactor of 2, 1. A21 is what? Here, this cofactor 1 is here 2 plus 1. That is here it comes minus 1, 2 plus 1. That is 3. 2 plus 1 is 3. So minus 1 of over 3 is minus 1. So minus 1 into this. Like we can find all cofactors. Then let us discuss about properties of determinants. Interchange properties. Suppose look at here. What is interchange property? The value of determinants remains unchanged if the rows or columns of a determinant are interchanged. Look at here. This determinant A is A1, A2, A3, B1, B2, B3, C1, C2, C3 like. So determinant remains unchanged. The rows or columns or determinants are interchanged. That is, I write A1, B1, C1 as a row, A2, B2, C2 as second row, A3, B3, C3 are third row. That means rows and columns are interchanged. Let it be this is arrays. After interchanging that matrix, now the both determinant is equal. Means the any square matrix, the determinants rows or columns are interchanged, the value will same. Second, sign property. The sign of the value of determinant changes if any two rows or any two columns are interchanged. Here, original matrix A is determinants A is A1, A2, A3, B1, B2, B3, C1, C2, C3. Let it be matrix B is that first row as it is A1, A2, A3. The second and third rows are interchanged. Look at here, B1, B2, B3 come here and C1, C2, C3 is come here. That is second and third rows are interchanged. Then determinant of A is equal to minus determinant of B. Means if any two rows or columns are interchanged, then we can say the determinant value is sign change. Next one, the zero property. The value of determinant is equal to zero of any two rows or any two columns. Determinant is zero if two rows or columns are equal. Look at here, this determinant A is A1, A2, A3, second row also A1, A2, A3, third row is C1, C2, C3. If it is like, then we can say determinant A equal to 0, not necessary to calculate, directly can put 0. Even the columns are same, that is first and second column or first and third columns are equal, then determinant value is 0. Means in any determinants, two rows or two columns are same, then you can say the determinant of that value is 0. Next one, multiplication property. The value of the determining becomes k times the earlier value of the determinant if each of the elements of a particular row or column are multiplied by this constant. Look at here. Here, determinant A is A1, A2, A3, B1, B2, B3, C1, C2, C3. Let it be determinant B is first the k, a scalar constant is multiplied throughout all elements of first row. If it is then second row and third row is same, then we can say determinant of A is equal to k times the determinant of A. Determinant B here, determinant of B. Determinant of B is equal to k times the determinant of A. That is the k take out. If k take out in first row, then it becomes A1, A2, A3, B1, B2, B3, or even in column also, if any value of k is multiplied all elements in one column, any one column, then the k taken out. So this is the result. Next one, sum property. If a few elements of a row or column are expressed as a sum of terms, then the determinant can be expressed as the sum of two or more determinants. Look at here. The first matrix is A1, A1 plus B1, A2, B2, A2 plus B2, A3 plus B3. Second row is B1, B2, B3. Third row is D1, D2, D3. Now, if that first row is addition of two elements, so we have to take out first A1, A2, A3, C1, C2, C3, D1, D2, D3, and second elements adding is separately at right, that is B1, B2, B3, C1, C2, C3, D1, D2, D3. That means this determinant is written as the sum of two other determinants. Now, properties of invariance. If each element of a row and column of determinant is added with the equivalent multiples of the elements of another row or column of determinant, then the value of the determinant remains unchanged. This can be expressed in the form of the formula. Ri is changed as Ri plus k times Rj, or column Ci, that is any column. Ci is expressed as Ci plus K times Cj. Look at here. This is determinant A is given. Determinant B is, look at here. The first row is written as element of the first row is added with multiple of the multiple of this third row. Look at here. A1 plus KC1, A1 plus KC1, A2 plus KC2, A3 plus KC3. Second and third row is as it is. Even in column also you can write. Next, triangular property. Here, the triangular property, if the elements above or below main diagonal are equal to 0, then the value of the determinant is equal to the product of the elements of the diagonal element. Look at here. This A1, A2, A3, the 0, B1, B2, B3, 0, 0, 0, 0. That means this is a prime diagonal, A1, B1, C1. Here, the downward triangle is 0. Then we can say, even this upside also, upside triangle above the prime diagonal, that upside elements are 0. Then we can say the value is simply A1 into B2 into C3. So for the Laplace expansion of nth order determinants. Laplace expansion of nth order determinants is this, not now. So far we discussed about determinant, what is determinant, what is its properties, we discussed. We have done. Please subscribe our YouTube channel.